So I'm going to highlight the groups. The groups are the vertical columns in the periodic table, and elements within a group behave in a similar fashion. An element, for example, in group 2, all of them have 2 valence electrons, and it's the valence electrons, the outside electrons, that govern the chemical properties of an element. So that's why they behave in a similar fashion, because they have the same number of valence electrons. The IB wants you to know about the trend in reactivity down group 1. As you go down group 1, the reactivity increases. So francium's the most reactive. Francium's the most reactive because in group 1 it's the biggest one. And metals want to lose electrons, and the valence electron in francium is furthest from the pole of the nucleus, so it can be easily removed. And as you go up group 7, the reactivity increases. So that's the opposite pattern. As you go up group 7, the reactivity increases, which gives you fluorine as the most reactive element in group 7. That's because if you have a lone electron and all the halogens love electrons, the electron would much rather go to fluorine because it can get closer to the positive nucleus there. It's the smallest atom in group 7. So the 3 sorts of reactions we need to know. First of all, reactions of the alkali metals in water. So you saw that before. The alkali metal reacts with water to form the hydroxide and hydrogen gas. Don't forget to balance it out. I've not put the state symbols in because I'm being a bit lazy, but you probably have to. Lithium hydroxide, that's a strong base, and if you dissolve it in water, it's being a strong alkali. Group 1 hydroxides are strong bases. And hydrogen gas is produced each time. You can remember that because the boat was fizzing along with hydrogen gas. Now, since lithium, sodium, and potassium are all in the same group, they're going to have a similar chemistry. In fact, the equations are pretty much identical. I'm just going to swap out the metal from group 1 for another metal in group 1. Now the chemistry isn't the same because the reactivity's slightly different. Lithium's the least reactive, it just goes fizz, sodium goes bang, and potassium goes boom. Just when you think it's not going to explode, it normally does. Alrighty, so the IB also wants you to compare these 6 elements' reactivities. Those 3 with those 3. The least reactive pairing, well, that would be lithium with iodine. The least reactive, lithium and iodine. And the most reactive pairing, well, that would be potassium with chlorine. Now, more reactive pairings are available, but those are the ones specifically mentioned in the syllabus. And at this stage in chemistry, you don't really have the tools to understand the full reason, so I'll just give you a partial reason. So halogens with halide ions. Just remember, the most reactive ends up as an ion. 99% of the time that's true in chemistry. So what do I mean by that? Well, let's look at an example. Bromine, that's red. And iodide ions, they're colourless. Now there's 2 things that could happen here. The first thing is that nothing happens. It's red, it stays red, nothing happens. The second thing is that I could make purple iodine and the bromide ion, which is colourless. Now, how do I know which of these is true? The most reactive ends up as an ion. Bromine's more reactive than iodine, and so in the bottom equation, bromine has ended up as an ion. Bromine's the most reactive. It's higher in the halogens. Now let's balance that out. You do need to know the colours. Bromine is brown, we saw that, but chlorine's green and iodine's purple. And that the ions, the halide ions, are all colourless. Not white, colourless. But I can't draw in colourless because you couldn't see it. Another sort of question, is this possible? Bromine and chloride, is it going to do that? Is it going to turn from red to green? Does the most reactive end up as an ion? Well, what's more reactive, bromine or chlorine? Chlorine's more reactive. No. Chlorine's the most reactive, it's highest in the halogens, and that doesn't end up as an ion, so no, that won't work. It won't turn from red to green. It's not going to work. And finally, what about this one? Chlorine and iodide. Does that make chloride and iodine? Will it turn from green to purple if I mix all this up? Yeah, that'll work. Chlorine's more reactive than iodine. It's higher in the halogens. So it's possible. Chlorine turns to chloride. The most reactive ends up as an ion. Oh, I never bothered to change my phone ring from the original Nokia. Excuse me. Or it all has to be aqueous.